A certain carbonate supposed to be reacted with dilute hydrochloric acid according to the following equation, and this is the equation. 1 gram of this carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. After the reaction, the solution needed 30 centimeters cube of 1 molar sodium hydroxide for neutralization. We will be given the density of HCl is 1 gram per centimeters cube. The first question, calculate the number of moles of sodium hydroxide that reacted. But before we go there, it is important that you understand what kind of reaction is this. Now, this HCl is reacting with the carbonate first, and the remaining HCl is going to react with sodium hydroxide. It means that this acid was in excess. It is more. Therefore, it will react with 1 gram of the carbonate. After the reaction is over, the remaining HCl is going to react with 30 centimeters of 1 molar sodium hydroxide. It is important to understand that. Therefore, calculate the number of moles of sodium hydroxide that reacted. That one is directly from here. We have been given that 30 centimeters cube of 1 molar sodium hydroxide reacted with the excess acid. Therefore, how do we get? We have been given the molarity of sodium hydroxide. It means that this is 1 molar. It means that 1 molar means that 1 mole, this is the moles, because molarity, you understand what is molarity. Molarity is the number of moles in 1 liter. So it means that this one is in 1,000 centimeters cube. We will find out that centimeters cube will contain how many moles, because that's what we want to calculate. So that is 30 times 1, we divide by 1,000, and that one will give us 0.03 moles. So the number of moles that reacted with the number of moles of sodium hydroxide that reacted with excess HCl is 0.03. It is very important to know that. When you have molarity, I can give you another formula you can use. There is a triangle here which says like this, because we have here, right here, molarity. The space is very small. Let me increase this space. Molarity, volume in liters. This volume must be in liters, moles. So how do you can use this formula and you will get the same answer. How? So we have the molarity of sodium hydroxide, which is 1. We have the volume, it is 30, and then we want moles. So how do you write this one down as moles equal to molarity, let me use M, times volume in liters. The volume must be in liters. A liter, so it is in centimeters, we convert to centimeters, to liters per 1,000. So it will be 1 times the volume, which is 30, divided by 1,000. This one will give you 0.3. So you can as well use this triangle. It is important. Part 2, determine the number of moles. Determine the number of moles of hydrochloric acid used in the reaction with the carbonate. Remember, the number of moles that reacted with the carbonate, we don't know that, but we can get that. First, we were given that 1 gram of the carbonate was dissolved in 50 grams of 1 molar hydrochloric acid. So first, let us find the volume of the hydrochloric acid, the total volume that was used, where the X carbonate was placed to react. We have been given, we know that the density is equal to mass over volume. So we want the volume, the density we have been given, that is 1. So 1 equal to mass, which is alright, we have been given the density of the acid as 1 gram per centimeter cube. It means that 1 gram of the acid is in 1 centimeters cube. So we will find out 50 grams of the acid will be what? So it will be 50 times 1 centimeters cube, 50 grams, divided by 1 gram. So gram, we will have 50 centimeters cube. In short, when we have the volume given in grams, it is as good as centimeters cube when the density is 1, when you are given the density. So you should know that. So now we have that 50 centimeters cube of HCl was used. So we know the molarity of the acid, it is 1. Therefore, it means that 1 mole is the number of moles in 1,000 centimeters cube. What about 50 centimeters cube of HCl that was used? 50 times 1 divided by 1,000. This one is going to give us 0.05. Remember, this is the number of moles of the original HCl. Now we want to know the number of moles that reacted with the carbonate. Remember, the remaining HCl that was in excess, the number of moles is 0.03. Why? The ratio of sodium hydroxide and the HCl is 1 to 1. So you should know this. Sodium hydroxide, which reacted with excess HCl, the ratio, the sodium chloride plus water, the ratio is 1 to 1, meaning that the number of moles of sodium hydroxide will be equal to the number of moles of HCl. We know the number of moles of sodium hydroxide is 0.03. It means that the number of moles of excess HCl is 0.03. Now, if this is the number of excess HCl and the total number of moles was 0.5. Now, what will be the number of moles of HCl that reacted with X? Itakuwa 0.05 subtract 0.03. Therefore, the moles that reacted with the cup of HCl that reacted with the X carbonate is 0.02 moles. Very important. Next question, calculate the relative molecular mass of X carbonate. Relative molecular mass, RFM, of X carbonate. Now, we know that the mole ratio from the equation, we have this equation, the ratio of the X carbonate with HCl is 1 to 2. That's what I have written here. But we know the number of moles of HCl was 0.02. So what will be the number of moles of the carbonate? The carbonate will have a half of the number of moles. Therefore, moles of X carbonate is a half times 0.02. And that one will give us 0.01, and that is the number of moles of the X carbonate. Remember the first triangle in the topic moles, the concept mole. We have the RFM, we have moles, mass. How do you calculate RFM? So RFM is equal to mass divided by moles, which is equal to mass. Remember, the mass of the carbonate was 1 gram. 1 gram of the carbonate was dissolved in its 50 centimeters cube. Therefore, the mass is gram. Therefore, 1 divided by the number of moles, which is 0.01. This one will give us 100. Therefore, the RFM of the X carbonate is 100. Hence, give the relative atomic mass of X. So we want to calculate the relative atomic mass of X given that carbon is equal to 12, oxygen is equal to 16. So X carbonate will give us the RFM, which is 100. But X we don't know, so X plus carbon, which is 12, plus oxygen is 16 times 3, will give us a total of 100. So X plus 12 plus 48 will give us 100. X plus 60 is equal to 100. So it means that X will be 100 minus 60. It means that X is equal to 40. Therefore, the RFM, or the relative atomic mass, the RAM of X is 40. 20 centimeters cube of a solution containing 4 grams per liter of sodium hydroxide was neutralized by 8 centimeters cube of dilute sulfuric acid. Calculate the concentration of sulfuric 6 acid in moles per liter, right? So we want to find the concentration of sulfuric acid in moles per liter. Anytime you hear the word concentration in moles per liter simply means molarity, because molarity is the number of moles in 1 liter. So whenever you hear concentration in moles per liter, it means molarity. I have given this triangle here. So first, let us get the concentration or the molarity of sodium hydroxide. Sodium hydroxide is written as this. Sodium hydroxide is that way. And we can get the RFM of sodium hydroxide at 23 plus 16 plus 1, which is equal to 40. So how do you get the molarity of sodium hydroxide? So molarity, the formula is here. Molarity would be equal to mass, which must be in grams per liter, divided by RFM, divided by RFM. Now we were given the solution containing 4 grams per liter sodium hydroxide. So we have that 4 divided by the RFM, which is 40. So the molarity of sodium hydroxide is 0.1 capital M, or 0.1 mole per liter. 0.1 mole per liter. That is what we call molarity, or concentration in moles per liter. Now that we have the molarity, let us see the relationship. So you must write the equation so that you can check the mole ratio. But before that, let us know the number of moles of sodium hydroxide that reacted with the sulfuric acid. How do we know? Now we know the number of moles in 1,000. We will ask, what about 20? We will ask that here, that 1,000 centimeters cube of sodium hydroxide contains 0.1 moles. This one. What about 20? This volume here, centimeters cube of sodium hydroxide, the one that reacted, will contain how many moles? So that is 20 times 0.1, we divide by 1,000, and that one simply gives us 0.002 moles. So the answer is 0.002 moles. Yes. Next, now let us check the relation. So we have to write the equation, a balanced equation. So sodium hydroxide reacting with sulfuric acid, it gives us sodium sulfate plus water. So we need to balance the equation. Sodium here, there are 2, so we put it 2 here. How many nitrogens? These are 4, so we put another 2 here. But we have the number of moles of sodium hydroxide, which is 0.002 that reacted with this. Now, since the mole ratio of sodium hydroxide and HCl is 2 to 1, it means that moles of sulfuric acid that were used here equal to a half, because it is 1. So a half of times 0.001 are 2, which will give us 0.001. So the number of moles of sulfuric acid is 0.001. Using the mole ratio, stoichiometric equation, you need to understand that. But we know the volume of HCl, of dilute sulfuric acid that was used, 8 centimeters. So it means this number of moles, 0.01, is in this. What about 1,000? As simple as that. So we will ask, 8 centimeters cube of sulfuric acid contains 0.001 moles. We are asked to calculate the number of moles in 1 liter. So we will ask, 1,000 is 1 liter. Centimeters cube of sulfuric acid will contain how many moles? 1000 times 0.001 we divide by 8. This one will give us 0.125. Capital M stands for molarity, and the molarity is moles in 1 liter. Moles in a liter. Our next question. Sodium hydroxide pellets were accidentally mixed with sodium chloride. Yes. 8.8 grams of the mixture were dissolved in water to make 1 liter of solution. 50 centimeters cube of the solution was neutralized by 20 centimeters cube of 0.25 molar sulfuric acid. Write an equation for the reaction that took place. So it is important for you to understand that a mixture of sodium hydroxide and sodium chloride, this mixture, if the mixture formed a solution and the solution is reacting with an acid, the acid will only react with the base, sodium hydroxide. So the reaction is between sodium hydroxide and note the impurity. This one is just an impurity, sodium chloride. No reaction will occur with sulfuric acid. So let us write the equation. It is HCl, sulfuric acid plus sodium hydroxide, which will form sodium sulfate plus water. So that is the equation which will take place. Calculate the number of moles of the substance that reacted with sulfuric acid. So they are using the substance because they are not supposed to tell you that it is sodium hydroxide that reacted with sulfuric acid. You should know that a base will react with the acid and not the salt. Sodium chloride is a salt. However, that is why they are calling it a substance. So we know now the substance that is sodium hydroxide. So we want now the number of moles of sodium hydroxide that reacted with sulfuric acid. We have been given the concentration. We don't have the concentration of sodium hydroxide, but now we know the relationship between sulfuric acid using this equation. So we will start from what we know, the known to the unknown. We know that 20 centimeters cube reacted with it. So we started there that we have the molarity of sulfuric acid. So moles of sulfuric acid first. That's what we know. We know that 0.25 capital M stands for moles in 1000 centimeters cube, because this is molarity, and the molarity I have said that it is the number of moles in 1 liter. So 0.25 moles are in 1000. What about 20 centimeters cube, the one that was used? 20 centimeters cube will give us which number, what are many moles? So 20 times this divided by this will give us 0.005 moles. Since now the mole ratio for sulfuric acid and sodium hydroxide is 1 to 2, it means that the number of moles of sodium hydroxide is going to be twice the number of moles of this. So moles of sodium hydroxide is 0.005 times 2 because of the ratio. This is 1 and this is this. What about 2? This one will give us 0.01 moles. That is it. Calculate the number of moles of the substance that would react with sulfuric acid in 1 liter. Very correct. So the number of moles we have calculated here for sodium hydroxide is for the volume that was used, and the volume is 50. Now we want 1 liter. A liter is 1000 centimeters cube. So we will ask that 50 centimeters cube we got of the mixture is the number of moles which are containing 0.01 moles. We will simply ask 1,000 centimeters cube of that mixture, or that sodium hydroxide would contain how many moles? 1,000 times 0.01 divided by 50. This one will give you 0.2, because it is moles in 1 liter. That one is molarity, because you would simply write 0.2 mole per liter. Mole per liter. Therefore, that is molarity. Calculate the percentage of sodium chloride in the mixture. What is the percentage of this the impurity sodium chloride in the mixture? Now we have the molarity in a liter. That is the molarity. So what we want is to calculate the mass of sodium hydroxide itself in 1 liter. We will use this triangle. I think you have seen it several times. I will use this triangle that says that molarity, mass in grams per liter, RFM, right? So now I want mass of sodium hydroxide in 1 liter, in a liter. First, how do we get that? Mass of sodium hydroxide in grams per liter. So mass in grams per liter is equal to molarity times RFM. Molarity we obtained here, which is 0.2, and the RFM of sodium hydroxide is 40. This one gives us 8 grams per liter. So it means that only sodium hydroxide in the mixture contained 80 grams. But the mixture, so sodium hydroxide plus sodium chloride mixture contains 8.8. So it means that sodium chloride itself contains this one. So sodium chloride equal to the mass of sodium chloride will be 8.8, the total, subtract 8 for sodium hydroxide in 1 liter itself. So this one will give us 0.8 grams per liter of sodium chloride. But we are asked to calculate the percentage. So the percentage for sodium chloride is the mass, we divide by the total, 8.8, we multiply by 100, and this one will give us 9.09%. So that is how. So thank you very much. Please, there are other links in the description. Don't forget to subscribe. I love you very much. Thank you for your support.